Hi guys, this is Miss Scott. So today we're going to talk about congruence and triangles. And we're going to have a pretty short essential question today. What exactly are congruent figures? Well, in order to talk about congruent figures, we have to talk about congruent segments and congruent angles. So congruent segments are very simply segments that have the same length. So say I've got this segment here with a tick mark and another segment with the same tick mark. These segments would have the same length. And then we'd say they're congruent. All right, moving on. Congruent angles. So say we have this angle over here and this angle over here. If I have a double arc here and a double arc here, these have the same measure. All right, and we would call those angles congruent. Okay, now, a very important part about congruent figures is corresponding parts. And if you remember from the last chapter, corresponding just means matching. So these are just parts that match. So say we have this triangle here, and we have this triangle here. I'm going to call this triangle A, B, C, and this triangle D, E, F. And I'm going to put one arc on angle A and one arc on angle D. So that would mean like angle A corresponds to angle D. Those are the matching parts. And I could do that for the rest of the angles and the rest of the sides. So I could say angle B corresponds to angle E, angle C corresponds to angle F, and I could do that with the sides as well. Side AB corresponds with side DE, side AC corresponds with side DF, and BC corresponds with EF. So those would all be the corresponding or the matching parts. Now here's what we can say about congruent figures. We would say that triangle ABC is congruent to triangle DEF. This is what we call a congruence statement. And it's just a statement saying two figures are congruent. And really, if the figures are congruent, it means that all corresponding parts are congruent. And throughout this chapter, we're going to learn a few theorems of how much information do you have to have about a triangle specifically to know if they are congruent figures. So we're going to learn a lot about types of triangles that are congruent. All right, let's look at our first few examples here. So in the diagram, triangle EFG is congruent to triangle OPQ. Complete the statement. Something really important that you guys need to get used to is that in the congruent statement, the first letter in the first triangle corresponds with the first letter in the second triangle. Likewise, F corresponds with P and G corresponds with Q. So that is important. The matching letters are the matching angles, which creates the congruent triangles. All right, so let's look at segment EF first. So this segment EF is going to correspond or be congruent to OP. And if you look at your figure, EF are the first two letters, OP are the first two letters, so we know for sure that those have to be the congruent segments. All right, now let's look at angle P. We'll notice that's the middle letter in the first triangle, or the second triangle. So angle P, this angle here, is corresponding to angle F. So those are congruent. All right, angle G. So angle G is the last letter. That's going to correspond with angle Q. All right, now anytime you guys see the measure of an angle, you're going to actually put the number of degrees. All right, so if we're asked for the measure of angle O, well, they don't tell us how many degrees that is. But they do tell us that E is 110, and E and O correspond. So that means O also has to be 110 degrees. All right, now anytime they're asking for a length, they're not going to put this segment part over it. So since this doesn't have the segment, we are going to put the actual length of QO. So if we look at QO right here, well, they don't tell us. But we know that Q and O match with G and E. So these both have to be 7 kilometers. All right, and lastly, we're going to write a new congruent statement. Q goes with G, so we're going to say this is triangle G. O goes with E, and then P goes with F. Whoops, P goes with F. And if you look above, if you recall, we said that Q goes with G, and we highlighted that, so Q still goes with G. So that's not a very good highlighter to use for this example. And then likewise, O goes with F, or O goes with E, rather, and then F goes with P. All right, so that congruent statement still holds true. Okay, now let's look at when they don't give us the congruent statement, how we can come up with that. So we're going to write a congruent statement for the triangles. Let's do that first. So I'm going to call the triangle on the left triangle SRT. So I've got S, I've got R, and I've got T. So S, notice, goes with angle K. So it's congruent to triangle K. And then notice that R goes with L because they both have a double arc. And then T goes with J because they both have a triple arc. So this would be the congruent statement for those two triangles. And it doesn't really matter what order the letters are in as long as S goes with K, R goes with L, and T goes with J. Okay, so now let's do the second part. Identify all parts of corresponding congruent parts. So we've got 3 corresponding angles and 3 corresponding sides. Let's do the angles first. So angle S is congruent to angle K. That's our first one. Angle R is congruent to angle L. And angle T is congruent to angle J. So that would be one congruent statement with all of our parts. And then we have to do the sides. So this side ST goes with JK. Or I guess actually ST, S goes with K, so it's going to have to be KJ. All right, and then let's look at SR, that side there. So segment SR goes with KL. All right, and last but not least, RT goes with LJ. So RT is congruent to segment LJ. All right, so we've got 3 sides and 3 angles, so those are the pairs of corresponding congruent parts. In our next example, we're going to throw some algebra in here. So if we take a look at the diagram below, quadrilateral DEFG is congruent to quadrilateral SPQR. Find the value of x and find the value of y. So first let's take a look at x. So I noticed that in this second quadrilateral, they tell me that QR is 2x minus 4 feet. Well, QR are the last 2 letters here, so that is to match with side FG in this first figure, which I know that's 12 feet long. So I can take this and set it equal to this to find x. So 2x minus 4 equals 12. We can solve that. Add that 4 on over. These cancel. We end up with 2x equals 16. And if you divide by 2, x is 8. Okay, let's switch colors here so we can differentiate. So now that we have x, we can plug it in here. So we know that that's 8 now. And this angle here, 6y plus x, is angle Q, which is the third letter. So that has to go with angle F, which we know is 68 degrees. So we can take that 6y plus x and set it equal to 68. But hey, we just found that x is 8. So 6y plus 8 is 68. And we can subtract that 8 from both sides. Get 6y equals 60. And if we divide that by 6, y's got to be 10. All right, so we got our two answers here, both x and y. Okay, let's take a look at a third theorem. So coincidentally, the third angles theorem is theorem 4.3, and that just tells you if you have two triangles. So say I've got this triangle here and this triangle here. And if you know this angle matches with this angle, and this angle matches with this angle, then it turns out that this angle, I'll call it x, and this angle y, the third angles in each of the triangles, those have to be equal. So in words, it's just saying if two angles are congruent, so that means like this angle and this angle is congruent to this angle and this angle, then the third angles are also congruent, which we called x and y. All right, we might use that theorem in a moment here. Actually, we're going to use it right now. So, example 9. I've got this arc on angle A, and they're telling me that's 65 degrees. So angle D also has to be 65 degrees. And I know that this angle Y then has to be Y plus 65 plus this is a 90-degree angle if it's a right angle. Those three angles have to add up to 180. So I can combine some like terms. 65 plus 90 is 155. So y plus 155 equals 180. And if I subtract the 155 from both sides, y is 25. Okay, number 10 is kind of a tricky one. We're going to split this into four steps rather. So the first thing that I see is I know in this triangle on the far left angle 1, 2, and 3. So that means this also has to be the same as angle 3, because if you remember, those are vertical angles. So this is first thing I can say. All right. Then I'm going to take a look here, and I notice that I have 1 and 3 here. Actually, let's go back to that blue color. I'm going to make all the 3's blue so we can see what's going on here. And then I've got angle 1 here and here. So if this triangle has a 1 and a 3, this triangle has to have a 1 and a 3, but it's missing this 2. So this also has to be angle 2. That's the second thing we can say. All right, so now I know that's 2, meaning this has to be 2 because, again, these are vertical angles. So this is the third thing I can say. And now notice I've got a 2 and a 3 in this triangle, so that last angle has to be angle 1. All right, so that's my conclusion. That's the fourth step here. Okay, so angle A is congruent to angle 1 because first we used vertical angles. Then second, we use that third angles theorem, theorem 4.3, and then again we use vertical angles one more time to get that second angle in the last triangle. And lastly, we use the theorem 4.3 again to get that missing angle in this triangle on the left. All right, whoops. All right, last example here. I'll go back to that if you still need to jot any of that down. So very last thing we're going to mention here is pretty straightforward. It turns out that for congruent triangles, the reflexive property, symmetric property, and transitive property hold true. If you have a triangle ABC, well, triangle ABC is congruent to itself. And if triangle ABC is congruent to triangle DEF, then you can flip-flop those and say triangle DEF is congruent to triangle ABC. All right, and lastly, if ABC is congruent to DEF and triangle DEF is congruent to triangle JKL, then you can cut out that middleman and say triangle ABC is congruent to triangle JKL. All right, so thank you guys for watching. Don't forget to comment if you have any questions and subscribe to my channel if you can. All right, thank you guys, and we'll see you next time.